Hi friend, welcome back. In the previous lesson, you learned that the body needs to keep the physical and chemical composition of its internal environment fairly constant through the process that is known as homeostasis. But what happens when there are changes to the composition of the body's internal environment? Well, let's learn about that in this lesson. The human body has different control mechanisms that are used to restore the internal environment to its normal states whenever a change occurs. These control mechanisms the body employs to detect changes in its internal environment and to restore it to normal are known as homeostatic processes. Do you have an idea of how a fire alarm system works? Well, for some, a sensor detects heat, a rise in temperature, or the presence of carbon monoxide or smoke. Then it transmits the instruction to the central alarm panel, which activates the sounders to ring and warn people about a fire or turn on flashes to indicate a fire outbreak. The human body does about the same when there are changes to the composition of its internal environment. For a particular change within the internal environment of the body, there are a set of organs that are able to detect this change. These organs are known as sensory detectors. The sensory detectors recognize these changes and then signal or stimulate an appropriate part of the body that receives these signals. These parts receive these signals and send out instructions to a set of organs or glands, which are known as effectors. Now, the effectors finally react to restore the body's internal environment to normal. And that is the basic plan of the homeostatic process. A very good example of a homeostatic process is the regulation of blood glucose levels in the body. Now, after eating a meal, the blood glucose levels become higher than normal. This change in blood glucose levels is detected by the hypothalamus in the brain. The hypothalamus sends signals to the pancreas, which respond by releasing the hormone insulin to move the excess glucose from the bloodstream into the body cells, where it can be used for energy or stored for later use. When the blood glucose levels become low, such as after a period of night fasting, the hypothalamus sends signals to the pancreas to release the hormone glucagon, which helps to break down stored glycogen in the liver into glucose, which can be released into the bloodstream to raise blood glucose levels. This homeostatic process that involves regulation of blood glucose level is controlled by the brain and the hormones insulin and glucagon. Hormones act like messengers that help to transmit information within the body, while the brain is the main controller of the body's homeostatic processes. Now, aside the brain and the endocrine glands, which produces hormones, there are also other parts of the body involved in homeostasis, such as the kidney, the skin, and the liver. In subsequent lessons, we'll see how these body parts work together to keep the conditions of the body's internal environment steady.